problem from particle dynamics and from the chapter of coalition. And the problem is, if a sphere impinges directly on an equal sphere which is at rest with coefficient of elasticity is E. This coefficient of elasticity is also known as coefficient of restitution, right? Then a fraction K of the original kinetic energy is lost by the impact. Then K is, we have to find the value of K. Here 4 options are given. We have to find out the correct option. Okay. Before going to solve this proof, we see here we are use result, very important result of direct impact, because here it is given that impact directly. So here we let two sphere, this sphere and this sphere, the center of the sphere is C1 and C2, and so this is the line of impact. Okay, and let before collision the velocity are u1 and u2, and after collision velocity are v1 and v2, and the mass are m1 and m2. And here an important rule or important formula which is known as Newton experimental law of direct impact, which is given by v2 minus v1 by u1 minus u2. That is the difference between the velocity after collision and before collision, but taken in reverse order. Here we take v2 minus v1, but here we take u1 minus u2. This is equal to coefficient of elasticity or coefficient of restitution, right? And the second result is conservation of linear momentum. This is very easy result, m1 u1 plus m2 u2. This is before linear momentum and this is after linear momentum, after impact and before impact. So these are same. And loss of kinetic energy is given by, this is the kinetic energy before impact and this is the kinetic energy after impact. So the difference is the loss of kinetic energy, right? Now for the given problem, here two spheres are equal. Okay, so we draw a rough sketch of two spheres. This is one sphere and this is another sphere. Since two spheres are equal, so mass are same. Let it be m. And it is given that the second sphere which is at rest, so we say that u2 this is equal to 0 and u1 this is equal to u, we say. Okay, and after collision let it be with velocity v1 and it be with velocity v2. These are unknown of me. Okay, this is c1 and c2 and this is the line of impact. Now using the Newton experimental law first, we get the result as v2 minus v1 by, this is u1 minus u2. So u1 means u minus u2 means 0. This is equal to e. So we get v2 minus v1. This is equal to e into u. This is the first result we get. And from the second, conservation of linear momentum, we get that this is given by, we put m1, m2 all in place m. Okay, because the mass are m. So we get from here, we write directly, this is u plus 0 and the right side is v1 plus v2 by cancelling out m from the both side. So we get the result v1 plus v2, this is equal to u. This is the second result we get. Now we have to find the loss of kinetic energy. The loss of kinetic energy is half m. This is u, this is 0, so this is u square minus half m. This is v1 square plus v2 square. Okay, this is the loss of kinetic energy. And it is said that a fraction k of the original kinetic energy is lost. Here original kinetic energy means before kinetic energy. So this is, so loss is equal to k into original kinetic energy means half into m into u square, right? U square. Now cancel m from both sides and cancel half from both sides. We get the result as u square minus v1 square plus v2 square. This is equal to k into u square. Now we get the result from here. This is u square minus k u square. This is equal to v1 square plus v2 square, right? And we multiply both sides by 2. That is 2 into u square into 1 minus k. This is equal to 2 into v1 square plus v2 square. And we multiply by 2 because we use the formula. This is v1 plus v2 whole square minus v1 minus v2 whole square. This is not minus, this is plus. Okay, this is the formula of 2 into v1 square plus v2 square. Now putting the value of v1 plus v2 from here, this is u square, and putting the value of v1 minus v2 from here, this is e square into u square. Okay, now cancel out u square from both sides and we get the result as 2 into 1 minus k. 2 into 1 minus k, this is equal to 1 plus e square. That is, we get 1 minus k, this is equal to 1 plus e square by 2. So k is given by 1 minus 1 plus e square by 2. So this is half into 1 minus e square. This is the value of k. And clearly our correct option is option number B. Very, very interesting and important problem of direct impact. Okay, thank you for watching.